either a maximum or a minimum at 4 ohms. It is within the range because the range of the resistor is 1 ohm to 15 ohms, so we don't have to worry about the boundary conditions, whether those might be maximum or minimum value. We just need to somehow establish whether that's max or min. And it is simple enough. We came up with one value, so it's either looking like that or it's looking like that. So we're either here or here. And the simplest way is not to do the second derivative.
It's not.
I know that my boundary conditions are either going to be higher or lower. So let's see what happens with the boundary condition.
What was that?
All I need is one of them.
We'll use one.
Sounds good. So if I stick a 1 in here, I get 400 over 1 plus 8 plus 16. So that's 400 over 25.
16.
Really? Oh, yeah.
Oh, that's our power right there, so 16 watts. We need to plug that 4 in there to actually figure out what the power is. If I stick the 4 in, I get 1600 over 16 plus 32 plus 16. So that's 1600 over 64.
$25.
And we got, where is it? We had 16 watts, and we got 25 watts, so that's a maximum.
Oh, that makes perfect sense.
Or technically supposed to find one more point at the other extreme.
You think we reject the other point at the other extreme?
I mean, like another boundary point to prove it.
Well,
If you crank up the resistance to 15, wouldn't that be larger than the
but if you crank up the resistance up to 15, the current's going to be lower. And the current has a big impact there because it's squared. It's I squared. So if
Well, it makes sense that 1 would be higher.
So we had 400 times 15, I think that was the maximum, over 15 squared plus 8 times 15 plus 16.
Alright, yeah, and you get a 16.6.
There you go.
It's max.
And then the supplemental question that you can't answer here is, what does it need to be in order to actually make toast? But,
Me just throwing the bread on the stove. Me just throwing the bread on the stove.
Yeah, I know, it's just burn it, I don't care
Get the
anymore.
nice rings.
Exactly.
Throw it on.
Yo, you really do that?
No, but my
Alright,
mom
alright,
used
just
to
wanted
do
to make
that.
sure.
My mom used to do that. It worked.
With tortillas, it works good.
Put it
You
on
know
the
what I'm
grill.
talking about? Dude.
Grill my bread.
You grilled
Notice
tortillas?
on this problem,
No,
yeah, this was a
they-
tougher problem.
I'll tell you.
I did have some leading questions down here to help.
Ah, thanks.
It's not relevant. It's to get it like-
He thought of us little.
My hand.
That's right.
It's not like very-
Okay.
And then we have, and again, you will have a problem. Different numbers. Batteries will be pointed one way or the other. But this is basically, the last problem will be something very much like this.
Oh, like we went over on that Zoom meeting.
Yeah,
Could we run through it?
In 20 minutes?
yes.
Yeah.
to both.
Do up, down in China.
Is that thing still recording?
I hope so.
Yeah.
I did start it back up again, right?
Yeah.
Okay.
I
Yeah, I'm
hope
gonna
it's
have to
still
go back and
recording.
watch this like
A blinking
12
red
times.
light means.
I might just gather the family around.
I might just take
Zoom
those
if they're not
points.
in town.
Dude, my baby sits there and watches the Zoom class pretty much every day, so
How old is she?
6 months.
She's gonna be genius.
Yeah.
She's gonna have a big brain.
First
Now-
year is charged.
2 years from now. She's about to do.
I did tell, when I was making up stories for my son when he was a little one, I did the story of the quantum lion and started introducing certain conceptual aspects of quantum theory to him.
Quantum lion.
He actually became a physics major.
I love
Oh.
it.
No, yeah. That getting kids into hobbies, the younger they are, is like one of the most important things out there.
And
I was in
Big brain
Navy.
play.
I was in
Let's
Navy
see.
and the little girl, she was 3, she knew what I was doing, like going to school for engineering or whatever. And she didn't understand the whole like aerospace aspect of it, just the whole like rocket part. And now she wants to be a telescope operator.
Hey. That's pretty cool.
I'm 3 years old.
3 years old.
And she'll tell you like perfect, like just perfectly, that's exactly what she wants to do. And she would ask me questions that I would be like, I don't know.
I don't know, I can help you there.
I'm not quite there yet, but I'll let you know when
my daughter on the other hand,
I.
went the opposite direction of, I went anything else but physics.
What did you
English major.
do? Biology?
Actually, it was within the English department, it was communications and something else that,
Love that you don't
It's a
even know
shit-
what it is.
it's a, now she's doing, sort of a go-between between lab people and business people at a company in St. Louis.
But communications is, I think, the most taken degree major in Harvard. Like 70% of women take communications. It's like a crazy
I
statistic.
thought it'd be like psychology or something.
You'd think, but not. If I saw a video the other day of some dude who wanted to do interviews and just went around and asked girls what they did for majors, and like half of the girls he interviewed did communications. So.
I still
Maybe it's the
think-
communications ones are the ones that actually speak to them.
I remember people would be like, all the athletes who were there just for the sports and not for the actual majors would always try to be something like communication or religion or like theology majors.
I think education major is also a popular one for, and then,
I have still yet to meet another girl in the
Yeah.
program.
No, it's
Just me.
my
being
women's
like-
studies class asked me how many females I've seen in the engineering.
Only
program.
13% of engineers are women, and then of those 13%, 40% end up leaving the field within the first like decade. So for public speaking, I did like a whole speech on just pretty much like sexism in engineering and like how it's affecting women, and then also like how the industry is changing because of it. And yeah, a lot of kind of sad statistics, but I try to look at it as a way of like, I'm trying to change the statistic versus being like sad about it, you know?
Well,
I hope it becomes more successful. I have had years with 40% female in the 251, 252.
but it does just
Right,
happen.
it's-
For the past like year, all of my classes have been like all guys. I think this is the first time I have a class with other girls and it's Calc 3, and I really think it's just because it was the only section for Calc 3 for a while.
I work for an engineering firm right now, and we do have quite a bit of females.
Good,
Because-
good.
Workforce is
That's
really
at least like
nice.
reassuring to hear.
Yeah, at least in our department, telecom, there's a lot of people.
Generally
A lot of
speaking,
in there.
women really do just prefer people things. It's just that's just how it is. Because they
But-
have affirmative action for women in the STEM fields.
But is it because that's where they keep getting steered?
Well,
That's what
it's
I think
kind of
it's-
funny
studies
too,
go.
and there's not a single, there's not
Yeah,
one
come on.
right that a woman doesn't have, that a guy
Right
doesn't
up
have,
your
or a
alley.
choice that they don't have, that we don't have. It's
Yeah.
pretty equal across the
I'm
board,
so
and it's not like
sorry.
anyone forces you to do anything. right?
No, it's not a matter of,
I could be a hater
it's
if
the
I want
subtle, it's the subtle things.
Yeah.
If you look at the statistics of, because in order to get into here, you need the math background, and at some point, there's, seems to be an exodus from the more advanced math classes from the females.
Sure.
But relatively speaking, I mean, there are a lot of things go into it, but it's not just a gender thing. Because, for example, technically speaking, I shouldn't even be here right now. I'm the first one to ever go to a college, and I come from a very low income home. And you see me here, right?
Statistically.
Statistically speaking, I shouldn't be here. I'm from a single mother home.
I think
Raised-
based off. like
in
my,
an inner city community.
I think like based off my experience as a woman, I think that when children are growing up, at least in this area being more conservative, female children are not often encouraged to pursue certain things like this, or like in the STEM field, or STEM related as male children are. And I think like male children growing up are, you know, cars, trucks, planes, this, that, and the third, like it's all geared towards more stuff that is using like physics and computer science, things like that, versus like girls' toys are geared more towards like, oh, here's a Barbie, like here's made jewelry, and it's more, I think, like domesticated versus
Sorry.
based on my experience, yeah.
You guys are having a great, yeah.
Yes.
Physics?
Sorry,
Is
didn't
that
mean
what,
to.
wait a minute, Jacob, you were gonna try to bring us
I'm
back
just
to physics?
correction.
Okay.
Oh, I was just gonna say, I've seen things though where it's really interesting where they've done it on children based, like split on sex before they encountered toys.
Mhm.
And on average, boys go after cars and trucks more
I was
often.
gonna mention
And
that.
that's
but
boys
I
go after
didn't know
the
that.
moving parts.
All right, let's bring it back to physics.
Physics.
Sorry, we're not- If we
We
can
can
solve
talk
the
after
problem right
class if
now,
y'all want.
I'd love to keep going, but.
Very cool.
R1
It also depends
31,
on, like,
R2
for some reason,
31,
like, the health
R3
field, because
45,
mostly dominated by women,
R4
and I was, like,
14,
bringing
and
guys
change
in,
of
or, like,
voltage
teaching
for
too, so
3 is
it's kinda weird.
350.
Oh, so that's 35 volts, 16 volts.
No! Don't change it.
We're doing this problem.
It's the same one.
Oh, he didn't change it? Okay,
No.
good.
I haven't changed it from this, I assume you were gearing.
No, it's going up.
All right, so two choices, I have two junctions here. So I'm doing one current per path or one current per loop. One current per loop, also known as mesh analysis. So it does not matter which one you pick, just pick one.
Mesh analysis.
All right, for mesh analysis, I'm just going to arbitrarily just call that I sub A and I sub B. I went clockwise for no particular reason other than that just happened. So I'm not gonna have a junction equation because that's already sort of built in. I am gonna let A equal I sub A and B equal I sub B, just so I don't have to write as much. All right, so now we come up with our two voltage equations, because I have two unknowns, I need two equations. We have a choice of the left, right, or the whole thing. Doesn't matter, just pick two of them. So I'm gonna start here, out of habit, and I'm just gonna work my way, I'm gonna do the left one. So 7 minus 1A. Now across the middle one here, minus 3A plus 3B, because B is going up, and if I'm going against current, I am, think about it, if you're going against the current, you're moving uphill.
Yeah.
So you gain. Cross that battery, plus 35 minus 2A equals 0. Questions about this?
Where did the 3B come from?
All right, in the mesh analysis, I have two currents going up and down the middle here. And
Oh.
so at this point, A is going down and B is going up.
Oh, because both loops go through that same
Yes.
portion, okay.
Yeah.
Sorry, if, for the middle, between the two junctions, is that the other one, not mesh analysis? Where you take that as a current?
Oh, yeah, I have three currents. I have a current, left side, middle, and right side.
But doesn't the other path go through the voltage differently? So we have to also subtract 35 or no?
Because my voltage loop is independent of my current loop. In the fact that I'm starting here and I just have to end here. Now, I happen to also be going clockwise. So I go here, across, down, that's my voltage loop right there. When I go across my 7 ohm, or 7 volt, I'm going from the negative to positive. When I go across 35 in that direction, I'm going from negative to positive, so I gain. Because I don't care what the currents are when going across the power supply. All I care about is which is the negative and positive side.
Okay.
Cause if it was positive, negative, then you'd be losing those votes.
Yeah, if the battery would flip, then that would be a negative sign.
Mm-hmm.
All right, second equation, I got my right side, I got the whole thing. I'm gonna do the whole thing. I typically do right side, but let's just do the whole thing. So I got 7. So I'm doing this loop right here. I go across my 1 ohm, so that's -1 times that current, because I'm going with the current. I get here, I'm going with my IB, so that's -6B. I'm going against the 16, so plus, oops, sorry. -16, come back around, go across my 2 ohm, -2A equals 0. 2 equations, 2 unknowns. We simplify. So I got those, so that's 42. Then A,
-3, right? A? No.
6A.
Say minus
did I make a mistake?
Wait. Aren't the A's and B's flipped? Like, isn't it -6?
If I'm going with the current, I'm going downhill, I'm losing potential. So
Oh,
I'm
I
going with A, so I'm losing potential, so that's why
Okay.
that's minus.
Okay, that makes sense. Sorry.
The other equation, I got 7 minus 16, which is -9. -3A minus 6B equals 0. Assuming I have not made a careless error yet. And now it comes down to how do you want to solve it? It's a math problem now. Actually, a math problem once you got those two.
Let's take the top one.
Take the top one
42 minus 6A plus 3B equals 0.
and do what with it?
So we move 42 over, right?
Okay.
-6A plus 3B equals -42, which would then mean that 6A minus 3B equals 42. If we switch the signs around.
Okay?
Then, well, we could divide by 3 to get B by itself, and then we make B equal to something A.
So 3B is equal to 6A minus 42. B is equal to 2A minus 17.
Okay. So then we substitute B into our second equation.
All right?
So
To the A, so -9 minus 3A minus 6 times 2A minus 17. And now we solve for A. And then we plug back in to prove for B.
So I'm just gonna go ahead and take them all positive. So I've got 9 plus 3A plus 12A minus
Whatever 17 times 6 is probably like
102.
calculator.
So 15A equals 93.
No, yeah, my bad.
Did I mess up somewhere?
No, 93.
Well, then you get what, 93 divided by 15 is
I was actually expecting an
6.2.
integer, so it makes me think.
I got 5
All right.
as
Where-
for A and -4 for B.
Yeah.
Have
But
4
we
for
are
B
using-
and 9 for A.
We are using a method of leading coefficients. Correct. That's the process that we just went through.
Leading coefficient, so this was just,
That's technically like that.
we solved for an unknown plugged into the other, so,
It's-
whatever that's called.
Leading coefficients.
Is it? Okay, I would've, okay.
We did it in differential equations and I will like never forget it because we did so much, so that's the reason that I remember it.
But, all right, so,
I think that's supposed to be 3B equals, B equals 2A minus 14, not 17.
That might be bad.
Yeah.
so again, I do it in my head. So that makes this 90? No, 6 times 4 is 24,
84.
and so that's suddenly 75.
Okay. That's 5 right there. 15.
5 amperes.
So B, we got an equation over here, so that's 10 minus 14 or negative 4 amperes.
Not done yet. Let's see how well blue works.
All right, so A is a positive number, so we know it's going in that direction, so that's, I got 5 amperes flowing to the right across there. I got 5 amperes flowing to the left across there, and I have 5 going down like that. From B, I got a negative, which means the current's going in the opposite direction. So it's 4 amperes going to the left, or negative 4 amperes going to the right, whichever one. I've got 4 amperes here, and that's what I care about. So the current flowing across the middle, 9 amperes down.
And then everything else as is. The voltage across the 3 ohm resistor, if I'm going with current, I'm losing, so 9 times 3 is 27. That's Ohm's law, delta V is equal to IR. So 27 volts. If I'm going with the current, negative. Or 27 volts. Or 27 volts up.
Huh.
Now, the reason I thought that a mistake had been made is that if I'm just randomly putting down numbers, I usually use smaller numbers. The fact that I had 35 volts there indicated that I was trying to go for integers in my final answer. I've left this up to classes in the past. Do you want the final problem to come out with integers in the final answer? The plus side is if you get an integer, feel like you've done something right. The downside is if you don't get an integer, you're now stuck with a decision of how long am I going to spend to try to figure out where the mistake is.
You know what? No energy. That's gonna mess with me.
I don't think
I feel like if I come out with an integer, I'm gonna be suspicious.
Yeah.
Okay.
You know what I mean? I'm gonna be like, this same.
I'm gonna put down random numbers then, and it may or may not be an integer, I don't know.
Okay.
Okay.
Like
Sorry.
something